Hey everyone, Mr. Skelton here. We are back at it, Lesson 5, Unit 6. And today we're going to be talking about logarithms. And it's going to be a brand new concept for you. So I want to start out by kind of giving you some scenarios and give you an idea of what logarithms are, what they're used for, and how we're going to work with them today. So we're just going to scratch the surface. And today's goal is just going to be able to convert. So go back and forth between exponential form, which you already know, and logarithmic form. Okay, so let's go through a little example here. If I said 2 to the 4th power, right? You would understand that to mean 2 times 2 times 2 times 2. And 2 times 2 times 2 times 2, hopefully you know, is 16. Okay? And so what I want you to do is think about this in another way. I'm going to put 2 to the x power. Okay? And I'm going to put 2 to the x power equals 16. What I'm basically asking you to do here is solve for the exponent. Now, up to this point in time in your mathematical career, we have yet to do any algebra that solves for exponents. That's what logarithms do. Okay? Logarithms give you exponents. And I'm going to show you how that works here in a second. Okay? Now, you know already the answer is 4. But what we can do is, this is written out in exponent form here. What I'm going to do to your first introduction of logarithms is show you how logarithms are introduced to take this, which is exponential form, and convert it into log form. So if I were to take this and convert it into log form, here's what it would look like. We'd write log 2 of 16 equals x. Now, let me explain to you what you're looking at here. Here's what I always learned when I was in high school. Log. I would always read log as this. What power? Or what exponent? So I would read this as what power on 2 gives you 16? That's what we're asking, equals x, because what I'm saying is what exponent on 2 gives you 16? And whatever that answer is, we already know it's 4, right? We know it's 2 to the 4th, 4 would go there. What power on 2, so what power on 2 gives you 16, okay? So that's kind of what we're going to be doing. That's essentially what we're going to be doing today. This would be considered logarithmic form. Log form. Let's put log form, okay? This is exponent form. This is log form. So what you're going to, at the end of the day, what you're going to be asked to do is to be able to take something in exponent form and turn it into log form, but also go the other way. Take something in log form and go into exponent form. All right? I'm just going to slide this over, and in this column, I'm going to give you another example. So let's say 3 to the x power equals 81. All right? Now you may know what that answer is already just by doing some algebra. But if I ask you, okay, convert this into log form, turn it into a log form. So we would write log base 3. So we always write it below the g, okay? So it's a little bit lower. We call it log base 3. So what power, log, what power on 3 gives you 81, right? And we just kind of put it equal to x there. So this would be how you would write this, all right? So log base 3 of 81 equals x. So we already know that x is going to be 4 because 3 to the 4th power equals 81, okay? Now I know we got some examples down here and we'll get to it, but let's say, yeah, we'll just jump down to these because I've already given you a couple of examples. So let's just jump down here. So here's the two forms, and we kind of talked about this, and I wanted to give you another way to think about it. I like the way that I kind of just described it. It works for me. But you can see here, here's exponential form, okay? Here's log form. So if you want to, like, you know, memorize these two and understand, okay, the B stands for base, so that's the number that goes there. Logarithms always give you exponents, right? That's what I said in the beginning. Logarithms always give you exponents. That's the whole point of logarithms. The whole point of logarithms is right here. Logarithms give you exponents. And there's some other properties that we're going to get into, but a lot of students will go, logarithms give you exponents. The x here is the exponent on exponent form. That's why logs equal exponents. Logs equal exponents, okay? So we're just going to do some converting here. So you want to convert this into log form. So this would be log base 3. So what power on 3, well, we already know, it's 6, equals 729. Oops. Sorry, working too fast there. What power on 3 gives you 729? We know that is 6. What power on 3 gives you 729? We know it's 6, right? If they write something, you know, backwards, for example, it's okay to just write 5 squared equals 25. That's what I would probably do. So this, we want to convert this to log form. Log, in other words, what power on 5 gives you 25? We already know that's 2. So we're just converting, okay? So now we're going to go backwards. So this we want to translate into exponent form. So we would say, I just read this out loud, what power on 1/2 gives me 1/8? What power, which is 3, logarithms give you exponents, what power on 1/2 gives you 1/8? And that's how you would convert it. This is going to take you some time, all right? This is going to take you some time to get used to it, and you just got to practice, practice, practice. The nice thing is you can just make stuff up, right? You can go, you know, 3 squared equals 9. Okay, write that in log form. Well, log base 3, what power on 3 gives you 9? And you just convert it back and forth. And just go back and forth, back and forth, back and forth, and just make stuff up, all right? Let's turn the page here. So we're going to evaluate some of these logarithms. Now, a lot of times in the textbook, you won't see an equal sign. It'll just be like that. What I always do is I would write it as log base 4 of 64 equals x. So now we want to convert that into exponent form. If something is in log form, we want to go and convert to exponent form so that we can solve it. So how would we convert this? What power on 4 gives you 64? Now again, some of you may be able to do this mentally, but let me show you another way, because doing it mentally is great, but you're going to come across some problems where you won't be able to do that. So what I want to do here is I want to rewrite 64 as a power of 4. And you can take your calculator out, right? 4 times 4 times 4, and just try numbers. Oh, it is 64. So I can write this as 4 to the 3rd. Now, all I did was just take this 64 and rewrite it as 4 to the 3rd. Now, the reason I did that is because I want you to see when we solve these, I want you to notice that my bases are the same. When your bases are the same, you can set the exponent, or the power, equal to each other. What I mean by that is this. If your bases are the same, then you can set x is equal to 3. And that's your answer. Now, we all know that 4 to the 3rd power is 64, but I'm showing you this because it's going to apply to some other problems. So again, number 5. Take a look at this. This is what it's going to look like in your book sometimes. There won't be an equal sign and it won't say equal to x. You just have to look at this and say, oh, okay, I need to go log base 8 of 16 equals x. Now I need to convert that into exponent form. Well, what power on 8 equals 16? What power on 8 equals 16? 8 to the x equals 16. Now, if you look at this, right, 8 to the 1st is obviously 8. 8 squared is 64, so how do we get 16? What's going to go in here for x? So this is one where you can't do it mentally, right? But what we can do is rewrite 8. We can rewrite 8 as 2 to the 3rd, right? You can just take your calculator out. 2 times 2 times 2 is 8. Okay? So I just rewrote 8 as 2 to the 3rd. My x is still there. And I'm going to rewrite 16 as a base of 2, right? Because if my bases are the same, then I can write the powers equal to each other. So 2 to what power is 16? 2 times 2 times 2 times 2 is 2 to the 4th. So look what happens. My bases of 2 are the same. So what can I do? I can take my powers and set them equal to each other. Remember the exponent or the power rule, 3 times x is 4, divide by 3, and you get 4/3. See, that's a problem on number 5 that you wouldn't be able to do mentally. You actually need to write the same base, okay? Let's take a look down here at 6 and 7. I want you to try 6 and 7 on your own. 7's kind of tough, but I want you to give it a try, and then hit play, and we'll check back with you. All right, so again, just for review, you'll probably see that in a textbook, right? Or on your homework. We're going to put equal to x, and then we're going to rewrite it. 9 to the x, we're going to convert this to exponent form, equals 27. All right, so what's our job here? What do you need to do when you get something like this? Well, 9 to the first is 9, 9 squared is 81, so we can't use mental math. What we want to do is we want to make 9 and 27 and write them as the same base. So think of a number that has a base to an exponent that gives you 9 and 27. Well, I know 3 squared is 9, so I just took 9 and just rewrote it as 3 squared. There's my x, equals 27 is 3 to the third, right? 3 times 3 is 9, times 3 is 27. Now my bases are the same, so if my bases are the same, then I can take the powers and set them equal to each other. And I get x equals 3/2. That's what you should get for that one. Okay, 7, a little tougher. So again, we want to write it as equal to x. We got to convert this to exponent form. So log means, remember log means what power, so I just read what power on 64 equals 132. What power on 64 equals 132. Now, this one's a tough one. How do we rewrite the 64? Well, I know that 64 is 2 to the 5th power. Okay? You can just try stuff. 2 raised to the 4th, 16. All right? 2 raised to the 5th is 32. Sorry, it's not 2 to the 5th. I was even wrong. 2 raised to the 6th, 64. So look at that. That's why you got to do some trial and error sometimes. So 2 to the 6th power is 64 to the x. Now, I'm going to rewrite 32. I know it's on the denominator. Don't panic yet. So what's 32? 2 to the 5th, right? Again, try it out. We just did it. 2 raised to the 5th is 32. Now, you got to go back to your exponent days, but how can I rewrite this 1 over 2 to the 5th so that I get a 2, just a normal 2, as its base? Well, I'm going to have basically, if you remember, we can write this fraction as 2 to the negative 5, right? When you have negative exponents, back in semester 1, you'd have to rewrite it like this, 1 over 2 to the 5th. So now if you look at this, your bases are the same. We both have 2's. And now I can take my powers and set those equal to each other. All right? And then just divide by 6, and you get x equals negative 5/6. And that's our answer for number 7. That's a tough one, but hopefully that makes sense. All right, on the back, common log. You're going to see this a lot. It says it right here. If there's no base given, it's common log with base 10. So in other words, if you don't see anything here as the base, it's always a 10. Okay? It's always a 10. So the common log is always base 10. That's kind of how I write it. So on this problem right here, where you just have log of 100, you would go, okay, if it's log of 100, I would usually rewrite it as log base 10 of 100, just for my eyes, set it equal to x. Log means what power on 10 gives you 100, what power on 10 gives you 100, and we know that x would just be 2 because 10 squared, 10 times 10 would be 100. Okay, so that's important. You'll see a lot of these as we start to go through more logarithms where there's not always a base, and if there's not a base, you have to remember that it's always a 10 there. Okay. The last thing is kind of like a application to logarithms. Richter scale. You've probably heard of a Richter scale before when we're talking about earthquakes, right? This earthquake in California measured 4.5 on the Richter scale. Logarithms are a direct application, or the Richter scale is a direct application of logarithms. One thing that you're going to want to know and maybe write down is that they always have a base of 30. Okay? Richter scales always have a base of 30. So if they say there was an earthquake that measured 4 on the Richter scale, it's really 30 to the 4th power. If they measured something to they said, okay, on the earthquake out in California, measured 5 on the Richter scale. Now, a lot of people would say, oh, the difference between 4 and 5 is not that much. Whether it was 4 on the Richter scale or 5, it's not a big deal. Well, it actually is a really big deal, because 30 to the 4th and 30 to the 5th means that the difference between a 4 and a 5 on the Richter scale is 30 times more, right? 5 is 1 more than 4, so it's 30. It measured 30 times more powerful on the Richter scale. 30 times is a lot. So I know it doesn't seem like a ton of difference between a 5 and a 4 on the Richter scale, but it's actually 30 times more, and that's a big deal. So I think there's some questions on your assignment when we get to it that ask about the Richter scale, and if it said, okay, something measured, a 6 and something measured a 3 on the Richter scale, how many times more powerful was the first one versus the second one? And that would be 30 to the 3rd power, which is a big number. You can put it in your calculator, 30 raised to the 3rd. That's 27,000 times more powerful, and that's a really, really big deal. There's a big difference in power between something measuring 6 on the Richter scale and something measuring 3 on the Richter scale. So nothing too crazy there. I think I may have, like I said, I may have a couple application questions to you, but a direct association to logarithms when we start to deal with earthquakes in the Richter scale. Okay? Biggest thing I want you to take away from today's lesson is really just being able to convert, obviously, between exponential and logarithm forms. That's important. And then obviously the problems where you're figuring out what the exponent is, because remember, logarithms give you exponents. That's the most important thing to remember. I'm sure you'll have some questions, and that's what I expect. And I look forward to working with you in class and helping you iron out some of the details of this lesson. And we'll see you then.